if you're aging a vertical of Coca-Cola at home, as a quick aside,
1981.
a quick aside, I would say that roughly every 2 or 3 years we have, thank you alumni for your generosity, but we do not need you to donate your grandparents' old tin cans of
Tab.
whatever.
Tab or one
and
of the
old tuna fish,
yeah.
chunky soup.
Yeah.
I'm sure it's old, and there's some sort of research project we could do with 40-year-old cream of chicken soup. I don't know what that is. Please support Cornell in other ways. We don't need
the cash is better. Welcome to Research Matters, a podcast from Cornell University, where we explore how researchers are fixing real-world problems, one experiment, field test, or innovation at a time. I'm your host, Laura Riley. Today's topic might sound simple, but it's something most of us interact with every day, the aluminum can. You grab one from the fridge, pop the tab, you don't think twice. But inside this humble can, a lot of chemistry is happening, and sometimes it can cause big problems for the beverage industry and for sustainability, even human health. My guest today is Dr. Gavin Sacks, professor of food science at Cornell University, whose research connects chemistry to the flavors, aromas, and shelf life of the drinks we love, from wine and beer to kombucha and canned cocktails. Gavin, welcome to Research Matters.
Oh, thank you for the invitation to be here. I love talking about cans.
All right, so I guess let's start with cans seem to be everywhere. They seem to be crowding out. If you just go to the grocery store and down that aisle, they seem to be crowding out all the other all the receptacles. Yeah. Why is that?
Yeah. I mean, to put a number on it, I mean, the numbers I've seen are 3/4 of new beverage offerings are going into cans, and there's a pretty good chance if they didn't go into can, the manufacturer probably tried to put into a can. So I've asked my students, because a lot of these new beverage offerings, they are targeting 18 to 25-year-olds. And,
you're talking about like functional beverages?
Yeah, it could be functional beverages. It could be things like what I work on, wine, something that historically really hasn't been in a can, is now in a can. It could be energy drinks or rehydration drinks. And you talk to them and they say, well, I like that it's portable. It's lightweight.
Is it more single serve? Is that people don't want to open a bottle of wine, so a single serve?
Yeah, something like a bottle of wine. Especially if you imagine you're at a party with friends and everybody else is having a beer, maybe they're drinking from a can. Do you want to be that person awkwardly holding a glass, or for ready-to-drink cocktails, your favorite mixed drink? Well, everybody else has their beverage nicely contained. It sure is a lot easier and safer to have everything in a can, and plus maybe it helps you feel like you're fitting in a little bit. But furthermore, you go to the pool. You're going on a backpacking trip.
You're not breaking that glass.
You don't want to bring that glass. That's weight, and that's potential breakage. And then you ask, okay, well, what's wrong with plastic? First off, it doesn't look very nice. But then others, especially for students, people are concerned about the sustainability of what they're doing. Plastic can be recycled, but most of it isn't recycled.
So I actually just looked it up. So right now, there's actually been a slump overall in recycling, which is bad on all of us. Get back to it. I guess at our peak, we were at 50% overall. And now we're at 43% of cans or aluminum cans are recycled. 39% of glass and 20% of plastic. So that does tell a particular story. Are there other reasons? I mean, we're talking about it right now from the consumer point of view. From an industry point of view, are there advantages of the aluminum can over any other form of receptacle?
Yeah, cans are. Well, I mentioned the same issue that a consumer has with breaking and the weight of carrying something around. It's even more important to a manufacturer. A lot of the cost of making a product, it's not just the raw materials. That can add up, but it's also getting you the product, shipping it, putting on a truck or on a ship. Getting you the product is going to go as a function of weight. And if you're shipping something around in glass, that's just added cost. Plastic, if your consumer is asking about sustainability, then plastic doesn't look too good. It may not match the ethos of your brand. But the other nice thing about cans is you can decorate those everywhere. You can make you can use it as like a template or a background for any of the information you want. It's all over the can. And you can see these
You're
really
saying
creative
you can
labelings.
get the blank cans in and decorate,
And
kind of
so
wrap
there's
them?
multiple ways to do design, to do graphic design for those and to apply the inks. But the entire can is available, as opposed to a lot of glass packaging. The way that's done is you'll have a smaller label and then apply it. There's ways to try to use the entire bit of glass, but they're not cheap.
Yeah,
With
usually
can,
it's a front
much more
label and a
straightforward.
back label that's
Yeah.
the nutrition information.
Yeah, and plastic, it's often, if you can picture a typical plastic bottle, it's often very similar for plastic. You can design for cans entire sleeves that will cover the body of the can, and that can be used not just to give consumers information, but to advertise the product as well and make it distinctive.
All right, I want to get into kind of the chemistry of what's in the can, but before we go there, obviously tariffs are on our minds. And I remember that during the pandemic, let's say 2020 into 2021, there was a big aluminum can shortage. And the upshot of that was that the big, like the juggernauts, the beverage juggernauts, the Coca-Colas and the Pepsis got their cans. And it was all the little cutie pie craft beer guys were like way at the back of the line in terms of getting their cans because there was a shortage and it was mostly shipping, like supply chain shipping problems. Are there risks associated with having everything, kind of all of our eggs in the basket of cans? It's just a horrible metaphor, but
Yeah, and I'm not sure if the supply chain issues are unique to aluminum. There's a lot of beverage manufacturers and food manufacturers who very quickly learned about their supply chain logistics during the pandemic. And the strategy that many have taken is to think about trying to, as best they can, have contracts lined up ahead of time. Don't try to make purchases 2 weeks or a month in advance. As best you can, try to secure the cans that you need well before you know you're going to need them. And that can often work, but it still is a challenge for the small producers. That dynamic that you mentioned where the largest manufacturers are going to be able to make their supply chains work, and the smaller ones struggle, that doesn't change. But you also see now, like what I've seen in conversation, is some of the smaller manufacturers coming together and saying, we probably need to start having buying groups, buying consortiums, so we can go in together to try to get more favorable pricing, to try to negotiate getting cans of the specifications we want when we want them, as opposed to taking whatever is left over, perhaps that was rejected by the larger operations. But this continues to be a challenge, but it's a challenge throughout the food and beverage world, where if you're a small producer, getting the materials that you need can often be tough.
So do we produce aluminum cans domestically now, or is it still a matter of
Yeah, the aluminum can manufacturing is primarily domestic. However, the aluminum production, a lot of that is coming from other countries. We don't have a big domestic aluminum production. We're sourcing from other countries. Canada, for example, has been a big supplier, although as tariffs come and go, contracts often have to adjust for that. This is another appealing factor about recycling. You mentioned that aluminum rates are not as good as they could be, but they're still higher than other products. One of the nice things about aluminum is it takes less energy to produce an aluminum can from a previous aluminum can than it does from raw ore. And so that's an advantage then to domestic producers if they can source aluminum cans.
So I guess I didn't really fully understand that in most aluminum cans there's some kind of plastic liner. Can you tell us a little bit about that? I think that's maybe like one of those things that flies under most of our radar.
Yeah, we call an aluminum can, it's a plastic bag. And
what?
It's a plastic bag, but it's a plastic bag that is incredibly thin. So the aluminum part, the metal part, that's just there to keep the plastic bag from falling to pieces. That plastic bag, or we call it the liner or a lacquer or coating on the inside, imagine the thickness of a plastic bottle, typical drinking bottle. That's about 100 microns. So to put that in perspective, your hair would be about 100 microns in thickness.
And getting smaller all the time.
So we keep the next size down from that picture, saran wrap, like plastic film. That's going to be about 10 microns. The coating on the inside of an aluminum beverage can is typically 1 or 2 microns. So it's this incredibly
So
thin
is that just
coating.
that gets recycled along with the
Yeah,
aluminum?
well,
Is it problematic?
that can't be reused. Instead, that would get burned off usually. So there's a strong
Oh.
incentive to producers. That costs money, that plastic. And furthermore, that is going to eventually be plastic that won't get reused. So there's an incentive to can manufacturers to figure out how can we make that liner even thinner going forward. But the amount of plastic that's going to be on the inside, it's about 100 times less in an aluminum can as you would have in a single serving plastic bottle for comparison. And this is critical to have because otherwise the aluminum can would react with almost all beverages, and you would start seeing corrosion. That is, you would start to see that aluminum breaking down and stop being a container.
Okay, so I do want to get into so obviously there are all kinds of, depending on what, how acidic, what the, I mean, I'm sure it's way beyond pH, but there are all different kinds of factors go into corrosion inside a can. What's happening in there, and what can we control?
Yeah, you may have seen these reactions involving aluminum before at home. So if you have, for example, aluminum foil and it's in contact with something acidic, you put it over that half-used can of spaghetti sauce, and you pour it into a bowl and cover it up with aluminum foil, and you come back and now there's a hole in your aluminum foil. That aluminum has now undergone
Are you throwing
corrosion.
away that spaghetti?
It's going to probably taste a little bit metallic, most likely. You'll probably be okay. I don't want to encourage anyone in the listening audience to go out and try doing that and tasting it. You've just done corrosion. The aluminum has undergone oxidation. It is now dissolved into that tomato sauce.
Is it risky? I mean, is it bad for human health?
Yeah, I mean, aluminum at high levels is toxic, both in a very short term, but also over very long term. The amount, if you were to do that experiment I just described at home, you're probably going to be okay in the short term.
Throw away the spaghetti.
Yeah, it's still not worth it. You're still going to notice a off flavor associated with that aluminum. So aluminum is well known to be astringent. That is to give us this drying sensation. So it's the same feeling actually as like green tea or red wine.
Tannins
It's going to be very similar to the effect that tannins would have in your mouth. Aluminum salts do the same thing. I don't know if most people want that feeling when they're eating their spaghetti sauce, for example. So the same thing would happen in a beverage can. You mentioned pH. Due to the low pH of most beverages, that's what would happen with Coca-Cola, for example, or any other soda or a juice. If you were to put that into an aluminum can that had no liner, within days, weeks, that can would have corroded. It would have made a hole just like with that spaghetti sauce, and you will start seeing leaking. So we need to have that liner there. Otherwise, that can is going to stop becoming a can very soon.
Wow. All right. So you work on some of the compounds that are in beverages that are going to corrode that can interior faster or slower. We're at a moment with MAHA, and the federal government is trying to do away with a bunch of the artificial dyes and bring in natural dyes. Are those kinds of things being taken into consideration? I know that a lot of times in a beverage, those natural dyes kind of fall out of suspension or have problems. Is that going to add complexity to storage of how long something can be in an aluminum can before there are problems?
Yeah, that's so beverage composition, and you bring up food dyes. So there are some things that go into cans, even though you can't see the dye when you're looking at the can. You can see it when it's on the lip of the can, or maybe you pour it into a glass. So we've one of the things that our group has been interested in is understanding how the components in beverages affect the long-term stability, the shelf life of that beverage. So we have this liner, but even though that liner is going to protect the beverage from the can and vice versa, it's not indefinite. We know, you can have a soda in your at home in your garage for months, maybe even years. eventually you're going to start seeing corrosion. And people in the audience may have had the experience of finding an old soda can and the can is half empty or maybe fully empty.
Isn't
So
that what do they call that? The angel share or
yeah,
something?
well, yeah, this is yeah, this is yeah. If it was bourbon whiskey or Scotch whiskey, most certainly this would be considered a feature. But here, I think you'd say this is probably considered a bug to the process. But that's okay. I mean, people don't expect to get, at least I hope, if you're aging a vertical of Coca-Cola at home. As a quick aside,
1981.
Yeah, a quick aside, I would say that roughly every 2 or 3 years we have, thank you alumni for your generosity, but we do not need you to donate your grandparents' old tin cans of
Tab.
whatever.
Tab or one
and
of the
old tuna fish, chunky soup.
Yeah.
I'm sure it's old, and there's some sort of research project we could do with 40-year-old cream of chicken soup. I don't know what that is. Please support Cornell in other ways. We don't need
the cash is better.
Yeah. Please, I mean, nor should you donate that necessarily to the food pantry. It's okay. You can throw it away. But most people are not trying to age their Coca-Cola for 2 years plus and don't have a vertical of different years in vintages in their garage. But then we have some products. And I got into this from the perspective of wine. There's some products where people were reporting that there were shelf life issues within not just a year, not even months, but sometimes in a period as short as weeks, they were having problems. And this is how we got interested is what is it about, say, wine, or you bring up artificial food dyes. There's certain food components that accelerate failure of those cans. And sometimes it's corrosion where you see product failure. You see the can start leaking. And when one can starts leaking, it only gets worse because it leaks onto the cans it's above and onto the ones it's above. And now suddenly you don't have only one can leaking.
You have a whole pallet.
You have an entire pallet that, and you know this, if you've ever seen a hot water heater have issues and you come home and there's a big puddle underneath, that's the uh-oh moment that a lot of beverage manufacturers have. And they say, uh-oh. And it's usually this big spreading puddle underneath a pallet or more of cans. So sometimes it's that. Sometimes, and this is where we got involved, in the case of wine, certain wines were developing off aromas in the can. Off aromas of rotten eggs, sulfurous off aromas.
So not what I'm looking for in a wine.
You look at the shelf talkers, like the thing next to the wines that say, with notes of, you don't want to see notes of burnt hair and rotten egg. Yeah, you keep on walking, even if it's on sale, you just keep on going. So this is where we got started. I got first one call back in 2018 with a winemaker saying, hey, we have a canned wine and it's got some rotten egg smells. I said, oh, okay, well, you must have had a problem with your winemaking. Around the third or fourth call like this that I got, I realized this is probably more than just a one-off issue with that winemaking. So
was there a culprit or was it a series of things?
So it ended up, we have one main culprit with wines. And it's related to sulfites that are added to wines. And you can produce a wine without sulfites. Sulfites or sulfur dioxide, they're added to wine for a couple of reasons. One is they're an amazing antimicrobial, broad spectrum antimicrobial. They'll keep yeast from growing. They'll keep spoilers bacteria from growing. Fantastic. There's other ways around that problem. The harder to replace function of sulfites is that they are an excellent antioxidant. And if you produce a wine with no sulfites, it's often going to have aromas that are reminiscent of sherry wine or walnuts or bruised apples. And it's not necessarily bad, but most consumers don't want that. So producers will have at least a tiny amount of sulfites present in their wine. And certain forms of these sulfites, it turns out, can react with aluminum. And when they do that, they produce hydrogen sulfide. And so the mystery was, why isn't the liner doing its job? And the same thing seemed to be going on with things like artificial food dyes. We were confused because artificial food dyes, not all of them, but certain ones, especially of the red family, if you put them in contact with aluminum, they weren't causing any problems. But then we put them into real beverages, we could observe this acceleration of corrosion. And in both cases, we could link this to problems with the liner.
So I think you're doing work on developing liners that are kind of fighting back, that are kind of have some kind of chemicals built into the liner. So what does that look like? And what does that research?
Yeah.
How are you doing
so
it?
I can start with the question of SO2 sulfites. What are they doing? It appears that some forms of sulfites can actually diffuse. They can act like a gas and go through the liner. And once they do that, they can reach the surface of the aluminum can. And at that point, they'll start to corrode it. Certain food dyes, they don't do this. Instead, what they do is they seem to be able to get into the liner and then allow other compounds to pass through. So they make the liner less effective. It's like a sponge. You can imagine a sponge when it's dry. When you first hit it with water, the water doesn't immediately go through and pass through. It needs to fully wet first, swell up, and then other compounds can pass through. So what we've been looking into is an idea that we've stolen from outside the food industry, which is to add anti-corrosive ingredients. And
So
this
is
is
it stolen from the auto industry, or
auto.
what's
You
the?
see this in marine environments a lot,
Sure.
because imagine they're often putting things in contact with salt water. You've got an engine that's going to be exposed to sodium chloride. Chloride in particular is highly corrosive. And one of the strategies to try to extend the life of aluminum components is to have them be bathed in a solution that contains something that's anti-corrosive, something that will migrate to the surface, attach to the surface of the aluminum, and slow down some of these corrosion reactions.
Okay, but it has to be consumer safe, right? So
Yeah, that's the
how
challenge.
challenging is that?
That was the problem. If you look at the list of the things that are routinely used to prevent corrosion, a lot of them are complete no-goes in terms of not just the MAHA movement. They would never be improved by any federal government under any administration. They're highly toxic, or maybe they're not so toxic, but they're so expensive you wouldn't consider using them. Or maybe they react with foods, or maybe they have sensory properties. And at the concentration you have to use them, it's going to have an off taste or an off flavor, and then you're not really solving the problem. So that's where we stepped in, was to screen a number of compounds for their anti-corrosive ability, but also to make sure we were doing this with a list of approved food ingredients that were from natural sources that were unlikely to be forbidden going forward as well.
They have GRAS approval already.
Yeah, they already approved, and then from sources where they're part of they've been part of the people's diet, both here and elsewhere, for if not decades and millennia. These aren't new things. They're things that if you put them on a food label, they wouldn't scare you. What we call clean labels.
Sure.
They're going to be naturally derived from plants or animal sources that people recognize, as opposed to long lists of compounds that might give people pause.
Sure.
And even if we're thinking that they're safe, oftentimes, especially when you're buying food, it's not just about what you're told is safe. It's about how does this product, when I'm looking at that ingredient list, am I comfortable buying this product? So that's what we're working on right now. And we've just submitted for publication some exciting work where we think we've identified a couple of compounds that can extend the shelf life. They're able to get into that liner and prevent further corrosion of things like sulfites, or prevent the damage that some of these compounds like food dyes would cause to the liner, where they swell the liner and make it more permeable to other compounds.
Well, this sounds like we're going to see even more things in aluminum cans if you're solving these problems.
Yeah,
so.
I sure hope so. I mean, what I tell can manufacturers and beverage producers is, I don't know if you want to put everything into a can, but I don't want you not putting in a can something you could have put in because you were worried that it wouldn't have enough shelf life.
Yeah.
Everything that you want to put in a can, you should be able to put into a can. Let consumer preference determine if it goes into a can, rather than the shelf life issues and corrosion issues. That's the case right now. So going forward, this could also affect products that are already in cans. We were talking earlier, there's plastic on the inside, not much, but some, on the inside of a beverage can. Can we use even less? So existing successful products, sodas, conventional beers, typical beers, those have been going to cans for decades, but they still need that 1 to 2 micron thick liner. Can we get that even thinner, use even less plastic? I hope so. And that's one of the things we'd like to work on going forward, both getting these corrosive beverages that can't go into cans, successfully can, but also things that are already in cans. Can we do it using even thinner liners than we have done before?
That is wonderful. So for our listeners, I would love to have you give them a great recommendation if they want to learn more on this topic or kind of adjacent topics.
Oh, well. So if you find yourself interested in corrosion,
and who
first
isn't?
off, good for you. And maybe corrosion and its intersection with everyday life. Put another way, like how do metals fall apart and due to the results of oxidation and related processes. There's an author, not a Cornellian, but still a really interesting author named Jonathan Walden, who wrote a book called Rust, The Endless War. Really good book. And there's an entire chapter on his adventures working with a large can manufacturer, taking one of their short courses and workshops to learn about corrosion in beverage cans. And that's actually the book that I reference or I refer my undergrads and grad students to when they're first getting started, just to get a general perspective on the topic of corrosion and how it intersects with day-to-day life. So again, it's Jonathan Walden, Rust, The Endless War.
Thank you. All right, well, that is about all the time we have. So Dr. Gavin Sacks, thanks for joining us and for reminding us that even something as ordinary as a soda can be full of extraordinary science. If you'd like to learn more about Gavin's work or his collaborations with industry and other Cornell labs, visit cals.cornell.edu. I'm Laura Riley, and this has been Research Matters, where science meets real life, one problem at a time.